simple interest, and compound interest. Okay, this is the finance portion of Math 1324. So first, let's start with simple interest. Okay, now, guys, for simple interest, there's like two formulas that you gotta know. Okay, this is the first one. I believe in the book it has I instead of INT, but I like to put INT because it stands for interest. Okay, so we're going to be solving simple interest. The INT or the interest is a fee paid to use someone else's money. The PV is the present value or the principal. R is the interest rate and is always in with a percent symbol. And the time is always in years. Okay, now these two formulas are the ones that you're going to be using. Okay, but let's derive to the other formula. Okay, if you notice, my interest is PVRT, so I'm going to substitute PVRT for the interest is, and then I'm going to factor out a PV, which is a present value. So this is my formula. This is my other formula. The future value is equal to present value, parentheses 1 plus the interest times the time. Okay, and the AFV stands for the sum of the principal and interest earned, or the future value. The PV is the present value or principal, the R is the interest rate, and the T is in years. Okay, this is what you need to know. If months are given, then the time will be given months over 12, because everything has to be in years. And for the interest rate must be in decimal. So say they give you a 5%, right? You're gonna drop the symbol and move the decimal place 2 places to the left. Or else another way you can do it is divide 5 by 100, and it's gonna give you 0.05, and you drop the decimal. Okay, let's do some examples. This is example number 1. It says Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for the 5 years. Find the total amount that Martha paid to her uncle, and how much interest did Martha pay? Okay, so here, which formula should we use? The interest formula or the future value formula? Does it matter? No, it doesn't. I mean, in this case, it doesn't matter. Okay, I believe I'm going to use the example, same example, and do it with I'm going to start with this formula first, with the interest formula, and then on the next slide, I'm going to use the future value formula, just so you know it's going to be the same thing. Okay, now, if we use this formula, it's going to give us how much interest did Martha pay. Then, to find the future value, right, it's going to be the present value, what she borrowed, plus the interest. Okay, so if you want to use this formula, then you have to, this one here goes with the interest formula. Okay, now, so let's start. Okay, so what are we looking for? We're looking for find the total amount that Martha paid to her uncle, right? And we're also looking for how much interest did Martha pay. So here, guys, right, what's given is a 12,000. This is how much money Martha borrowed. The interest rate is simple to see because it's a 1 with a percent symbol, so it's going to be 3.5%. But remember, we have to convert it into a decimal. So it's going to give us 0.035. Here's where most students make the mistake, is with the interest rate, because they put 3.5, okay, which is wrong. You have to move the decimal place 2 places to the left, and you drop the symbol, which will be 0.035. The time, right, is already in years, so it's 5 years. So all we do is plug everything into the formula, and we use a calculator. And here's my result. It'll be $2,100 that of interest that Martha pays. Now, to find how much total money did Martha pay to her uncle, right? It's going to be the money that Martha borrowed, which is $12,000 plus the interest. That will give us $14,100. So to answer the two questions, total Martha paid was $14,100, and how much interest did she pay was $2,100. Okay. Now, let's do the very same formula. Very same problem, but instead of using the interest formula, let's use the future value formula. Okay, just so you know that you get the same thing. So here, guys, right? So they give us 12,000. Again, the interest rate is the same, 3.5 will be 0.035, and the time is 5 years. Right, so all we do is plug them into the formula, just the way it is, and we use a calculator. You see, guys, this is the answer, right? For, I mean, how much money did Martha pay total, right? Now, if you use the future value formula, I mean, the future simple interest formula, then for the interest, it's going to be the future value, which was a 14,100 minus the amount that Martha borrowed, which was 12,000. And it will give us 2,100. So again, if you notice, we get the same thing for both using different formulas. I mean, both the interest formula, simple interest formula, and also the future value interest simple interest formula. So here, it's up to you what you want to use. Okay, so I did it both ways, just so you see that there's no difference. Simple interest continues. Example number 2. It says Mariana will need to pay a tuition bill of $7,500 for her daughter in 10 months. What dollar amount can she deposit today at 1.25 simple interest to have enough money? I mean, to have enough to pay the bill, the tuition bill. Okay. So here, guys, right? So here we have to use this formula. Why? Because they gave us the future value, right? This is the money, right? This is the future value because she wants to have 7,500 in 10 months. So this is the future value. So we have to use this formula here. So here it does matter. Okay. Now, so we're looking for the present value, right? Because it says here, what dollar amount can she deposit today? Today means right now, right? Which is the present value. So we're looking for the present value, and we want to have 7,500 in 10 months. So the future value will be 7,500. The interest rate will be 1.25%. Convert to a decimal will be 0.0125. And the time, right? The time here, guys, is not in years, it's in months. So time will be 10 divided by 12. Okay, remember, guys, like I mentioned on the first slide, that it's always the number of months by 12 if it's not in years. So it'll be the number of months divided by 12. Now all we do is plug into the formula, right? Now the book and also my math lab, they want you to use this formula here, which is correct. Okay, but I'm going to show you another way that'll be easier, because most students have a hard time when they plug into the calculator, right? Because you have to put a certain amount of parentheses so you can get the right answer. But I'm going to show you 2 ways, okay? So this is the first way that I'm going to show you. So present value, right? So the future value is 7,500. And on the bottom will be 1 plus 0.0125, which is the interest rate, times 10 divided by 12. Now, if you put this in the calculator, guys, on the bottom, you have to put parentheses, or else you're going to get the wrong answer. No, but anyway, right, or if you want, you can stop the calculator, guys, right? Stop it and just put the numerator, which is 7,500. At the bottom, just multiply them out, and you get 1.01041667. And then you can divide that. So that's your answer right there. Which would be, and then you have to round it off to the nearest penny, right? Because the nearest penny is to the hundredths place, which would be the 8. So you always go to the right of the hundredths place, and if it's 5 or more, then you add 1 to the hundredths place. In this case, right, is 0, so it stays at 0.68. Okay, now another way, right, without clearing the calculator. Because I remember when I took this class, I would have to stop the calculator, right? Stop it and just do it how I did it here. But I found an easier way that's more friendly for students using a TI-83 or a TI-84. Okay. So we're going to keep the same formula. This way, you guys don't have to remember too many formulas. So we keep the same formula, which is the future value equals to present value, parentheses 1 plus RT, close parentheses. So as we plug everything in. Now, I'm gonna plug this into the calculator, guys, just the way it is. 1 plus 0.0125 times 10 divided by 12. Okay. Then when you enter, you're gonna get 1.1041667. If you notice, it's the same thing as what's here in the bottom, right? Same thing. But now, right, I'm going to multiply it by the inverse. So you're going to hit the inverse key. That's your inverse key in the calculator. So once you hit that, right, this is what you see. You're going to see answer to a -1, which means the inverse. And then you enter the 7,500 and you get your answer. And that's the result. I think towards the last to the annuity problems, I'll be using this way, because this way is much easier for the students. If you follow my steps, it's going to become much easier to enter all the numbers. Okay, now let's do another one for simple interest. Now it says here, John received a $10,000 loan from his aunt to buy a car. His aunt charged him 2.5% interest. How long was the term of the loan if the interest accrued was $125? Okay, so here, guys, right? This is the interest that she had to pay back. Okay, so for this one, this is a formula that we use. That's my formula that we'll be using, which is this one here, because the interest accrued is my I. You see, on the second formula, which is the future value, there's no I there, so we have to use this one here. Okay, because this is the interest accrued. Okay. So again, what are we looking for? We're looking for how long was the term of the loan, right? So we're looking for how long means time. So the interest accrued, I mean, that's my present value, and the interest accrued was 125. Right? Now, and my interest rate is 2.5, right? Which is easy to see because it's the one with a percent symbol. Converted to a decimal will give us 0.025. And now plug everything into the formula. So here, guys, right? If we multiply 10,000 times 0.025, it's going to give us 250. Now we divide both sides by 250. And it will give us 0.5. 0.5, or it's going to be half a year or 6 months. 0.5 years or half a year, right? That's the answer. Okay, that's how long it will take. Now comes different types of formulas. Compound interest. Okay, for compound interest, you can use this formula or this one on the right. I believe the one on the right is much more student friendly. Okay, but these are the same formulas, right? If you notice, it's the same thing. My FV is the same thing as over here on the right. My PV is also in the same place. The difference is R divided by M is going to be my I. And my M times T is going to be my N. That's the only difference. Okay? Okay, now, the future value, FV stands for future value or the future or maturity value. The PV stands for principal or present value. Again, the R is the interest rate per period converted to a decimal. The M is the number of compounding periods per year. The T is number of years. Here we go, right? My I is R divided by M, which is the interest rate per period. And N is my M times T, which is the total number of compound periods. Okay. Now, we have to know also, guys, here, the key words for compound. Okay, for example, if in the problem it says yearly or annually compounded, yearly or annually, my M is going to be 1, because yearly or annually means 1. If it says bi-yearly or semi-annually, my M is going to be 2. Quarterly is going to be 4. Monthly is going to be 12. Weekly is going to be 52. And daily is going to be 365, or it depends on the book. At times the book wants you to use 360 instead of 365. If it's not specific about using 360, then you use 365. But most of the times, these type of problems will be more likely monthly or quarterly, or maybe yearly. Those are the most common ones used for this section here. And continuous is a different formula, right? So instead of being the formula here on top, it's going to be the future value equals to the present value, the E function to the RT. Okay, there's an example here. Okay, now how can we use compound interest? Because compound interest can be used to invest a certain amount of money without depositing additional money. For example, say that you have, say $1,000 in the bank. I mean, $1,000 in somebody gave you $1,000, but you have no use for it. So I say, you know what? I'm going to put it in the bank and put it on a compound interest. Compound interest account, and this way you can get money, right, for a certain amount of time. Okay, let me do an example so that way you can be more clear about this. Oh, you see, here it is. Example 4. You deposit $1,000 in an account at your bank that pays 6% interest compounded quarterly. How much money will be in your account after 5 years? And how much interest did you earn? Okay, so let's get a formula there. But I'm going to use this one instead. Hey guys, for the rest of the formulas they'll be using in this PowerPoint, you're gonna have to find 7 things, right? And here they are, the 7 things for compound interest, for annuities, and also for ordinary annuities, and also for future annuities and present value annuities. So we're gonna use 7 things. Okay. Okay, now. So let's see here. So what are we looking for? Right, we're looking for the future value because it says here how much money will be in your account after 5 years. Let's see. So then the money that you deposit was 1,000. The interest rate is 6%, which will be 0.06. The compounded the amount of time is being compounded is going to be quarterly, which will give us 4. The time is 5 years, right? Now the I is R divided by M. my R is 0.06 and my M is 4, which will give us 0.015. And my N is M times T, so it will be 4 times 5, which will give us 20. And we just plug into the formula just the way it is, right? There's my present value. My I is 0.015 and my N is 20. And it's very simple to enter into the calculator. So this is my result, right? Round it out to your nearest penny. So it's going to be 0.86. So it'll be $1,346.86 after 5 years. So how much interest did you earn? How much money did you deposit? Right? It was 1,000. And you earned $1,346.86. So we can subtract the 1,000 from what you earned in 5 years. So it comes out to $346.86, which is not too much, right, in 5 years. But imagine if it was like 10,000 or 15,000 or 20,000, right? That's when this will be like a large sum. A large sum of amount. Okay, now let's move on. Continuous. Now let's do the continuous compound interest. Okay, let's do the very same problem, but instead of compounded quarterly or annually, it's going to be continuously. The way it's different, which means, right, it's going to be a different formula. So this is a formula that we'll be using. So we're looking for the future value, right, again. So the present value is 1,000. My interest rate is 6%, which will give us 0.06. My time is 5, so it's 5 years, right? So all we do is plug everything in, just the way it is, right? But you have to be careful here, guys. It depends on what type of calculator you're using. If you're using the T83, T84, the new ones, you can actually just put 0.06 times 5. But on the rest, make sure that you put parentheses where the parentheses 0.06 times 5, because if not, the calculator is going to follow PEMDAS, which is order of operations. And if you put the parentheses, you might get the wrong answer, or you will get the wrong answer. Okay? So once you enter into the calculator, this is your result, $1,349.86. I think the difference was about $3, I think, because another one, it was $13.46. So the more time that is, the more time that is compounded, the more money you get. So after 5 years, there will be $1,349.86 in the account. And how much interest did you earn, right? So we do the same thing as before. We subtract what you earn in 5 years minus what you deposit, which was 1,000. That will give us $349.86. So there are my two answers that we were looking for. How much money in 5 years and how much interest did you earn? Let's do another example of compound interest. Okay, here we go. This is really like a problem. Like I try to use kind of live scenarios that way students can actually can know that these all these formulas actually do work, and you can actually I mean learn a lot of when you buy a house or when you want to save some money and stuff like that, guys, right? So for example, for this one here, for this example, it says I want to be earning an annual salary of 100,000 when I retire in 15 years. I have been offered a job that guarantees an annual salary increase of 4% per year. So every year it's a 4% increase. And starting salary is negotiable. So what salary should I request in order to meet my goal? Okay, so there's diagnose a problem here. Right, there's my formula right there. So, right, I get easier to input in the calculator. So there's going to be 7 things that you need to find. So I want to be earning, right, 100,000 when I retire. Right, this means this money that I want to earn is in the future. So it says, what salary should I request in order to meet my goal? So what we're looking for is a present value. How much money should I request right now from the company that's going to hire me? I want to be earning 100,000, right, in 15 years. My R, which is the interest, is 4% increase per year, which would be 0.04. Compounded, right? Compound here says annually, right? So compounded is going to be 1 because it says annually. The time is going to be 15 years. So my I is R divided by M, which would be 0.04 divided by 1, which will give us 0.04. My N is M times T, which would be 1 times 15 will give us 15. Now we have all the info. So all we do is plug them into the formula, right? And again, right, we're looking for present value. So again, I'm going to show you here, I think for the last time, how to, do it, everything step by step, but then after that, we'll be using the inverse key, okay? So first, you enter the right here, the parentheses 1 plus 0.04 to the 15th power. You're going to give us 1.80943506, and then you divide both sides by the value that I just mentioned, right? And then you enter into the calculator. So it's going to give you $55,426.45. That's a salary that you need to ask for right now. Okay, now, right? So now let's do it in the calculator, right? We're using a TI-83 or TI-84. So we got that there. So we're gonna enter input 1 plus 0.04 to the 50th power. It's gonna give you. You should see 1.80943506. Then you're going to hit the inverse key, right? Then this is what you should see on your screen. Then you're going to enter the 100,000, and you get your result. You see, again, this way it's a steady flow of the calculator. You don't have to stop the calculator, right? Or clear it, and then into the 100,000 divided by 1.80943506. All you do is with the simple steps without actually leaving the calculator. Okay, and I think from now on I'll be doing it this way. But you can do it any way you want. Okay, but from now on I'll be doing it this way because I believe it's much easier, especially if you're not real friendly with how to use a calculator. And this is very student friendly, right? But this is the formula that the book uses. Now comes future value of an ordinary annuity. You see, so again, the formula on the left and on the right are the same because my I is the same thing as R divided by M, and my N is M times T. Again, right, there's your 7 things, and here's what everything means. Okay, guys, future value ordinary annuities can be used to accumulate funds for some time in the future, but you must set regular deposits during the specific time. Okay, let me show you here 2 examples of what I'm talking about. Okay, let's say that you can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. That means that from every paycheck, or I mean, say for example, like in structures, we get paid once a month, right? So if I was going to set up this type of annuity, I will have to give payments of $1,000 every month for every paycheck, because we get paid once a month. So you can set up the direct deposit that they take that amount from your account every month, right? So you're going to do that for 20 years, and you see how much money you have in the bank. Okay, now here's another example. Let's say that you are planning on sending your just born child to college when he or she turns 18. Since college tuition is constantly on the rise, you want to make sure you have enough money in 18 years for your child to attend college. Because in this example, I like to tell my students that because most students, I think at EPCC, they receive financial aid. So I tell my students that once your kids are 18, more than likely they're not qualified for financial aid. Why? Because you'll be making good money, because that's the reason of coming to school, is to improve our lifestyle and be safe financially. That's the purpose of getting a degree, college degree, and working is something that we want. So if we get the job that we want, right, then more than likely your kids will not qualify for financial aid or maybe partial assistance. But you want to make sure that you have enough money in the bank so the kid or your kids can attend college. So I'll be doing these 2 examples just to show you how they work. Okay, now, again, you can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. An investment company offers 3% interest for 20 years if you deposit $1,000 at the end of every month. How much money will you have in 20 years, and how much interest will you earn? Okay, because 3% right now is more or less about the going rate. I recall back in the 80s and 90s, it used to be like they will give you like 9 or 10% because they want to use your money. But now, especially after COVID, they won't offer you that much money. Okay, I believe during COVID, I went to see about an account, and they said that they were going to give me back like 1.5%, which I declined because it's not much. But 3% is like the going rate right now, maybe from 3 to 4%. So let's see how much money you have in 20 years if you would do some type of an investment in this type of situation that you can afford to pay into the account $1,000 every month and see what the results are going to be. Okay, this is my formula. Those are 7 things. So so we're looking for how much money, right, in 20 years, and we're looking for the future value. Your payments are going to be $1,000 every month. They offer you 3% interest, which will be 3% will be 0.03. It's compounded. Let me see here. Every month was going to be 12 because every month is 12 or monthly. The time is 20. So my I will be R 0.03 divided by 12 will give us 0.0025. My N is M times T, so 12 times 20 will give us 240. So now let's plug everything in. Now, remember guys, I told you that, okay, this is again, the long way, right? So it's going to give us that. And now this is my result. You're going to have $328,301 in 20 years. $328,202. I'm sorry about that. Now, again, how we can use the calculator. So here we go in one steady flow. Right, so this is how you put in the calculator. You can input, if you notice, all the numerator. Parentheses, 1 plus 0.0025 plus parentheses to the power of 240 minus 1 in the calculator. And this is what you should see, right there in black. Then you're going to hit the division key, right? Because you're going to be dividing by 0.0025. This is what you should see on your screen. And you're going to enter 0.0025. And this is what you should see on your screen. 328.301.9981. And then, right, you're going to enter the 1,000. Enter 1,000. And that's the answer, guys, right? So we got the same thing. $328,301, which runs off to $328,302. Because here, guys, is 0.99. And remember that you go to the third place of the decimal. If it's 5 or more, you add 1. So you add 1 here, it's going to give us, it's going to go all the way to 302. So it'll be $328,302. So now, how much money will you have in 20 years? So that's my answer for the first part. And how much interest will you earn? So how do we do that? Well, here's how. How many payments did you make? You made 240 payments, right? This is how many payments you make, 240. And the payment was for 1,000. So 240 times 1,000 will be 240,000. So we subtract how much money you earn, right? The total. Subtract the 240,000 from it. So you made $88,302 extra, which is not bad for 20 years, right? Just for doing some kind of account like that. So that's the answer, is $88,302. That's how much extra money you made. Okay, now let's do one more. Here we go. Okay, you are planning on sending your just born child to college when she turns 18. You want to have at least $250,000 in an account for tuition in 18 years. How much money must you deposit at the end of each quarter in an account paying 5% compound quarterly? Again, there's my formula. Doing the 7 things, right? So again, we're looking for the payment, right? How much money will you deposit right now? And this is 250,000 is the future value. That's how much money you want. They offer you 5%, which will be 0.05. Compounded quarterly, which will be 4. The time is the same as before. No, it's 18 years. The I will be R divided by M. 0.05 divided by 4 will be 0.0125. And the M times T will be 4 times 18. 72. So now, hey guys, remember guys, here guys, right, we're looking for the payment. So in this case, we're going to use the inverse key. Okay. Anyway, guys, here we go. We're going to input parentheses 1 plus 0.0125 close parentheses to the 72nd power minus 1. And this is what you should see on your calculator. 1.445920268. Then you're going to hit the division key, and then you're going to enter 0.0125. And you should have 115.6736215 on your screen. And then here, guys, right, this whole amount on the right side is 115.6736215. Now you're going to hit the inverse key. When you hit the inverse key, this is what you should see on your screen. And then you're going to enter the 250,000. So you need to deposit $2,161.25 every quarter, which means every 3 months. Right? That's a payment every 3 months, which is not bad. Right? Not bad at all. Now, but that's if you can afford it, correct? Now, how much money did you actually pay? I mean, did you actually put into the account, and how much interest did you earn? Okay. Okay, this is the extra information. How much money did you put into the account? So how many payments are there? There's 72 payments. So you multiply 72 times the payment, which will give you $155,610. Then, right, really, that's how much money came from your pocket, and you got 250,000, right? So that came from your pocket. So you subtract that amount from the 250, which made about $94,390 in 18 years, which is very, very good, right? All that money you got extra. Okay. Now comes different types of problems. Now comes the present value of an ordinary annuity. On the previous 2 slides, we did the future value. Now it's the present value. Okay. Now how does this work? Here's some examples. Present value of an ordinary annuity. The most common use of a present value of an ordinary annuity are for purchasing an expensive item, such as a vehicle or a house, at the present time and making equal payments, including interest for a certain amount of time in years. Okay, because this is what most students like about this finance section, because most students, they want to buy a car, right, or they want to buy a house, and you'll be amazed how much money you can save by knowing how this formula works. Okay, so let's get some examples. You want to purchase a car. What are your monthly payments, and how much will you end up paying for the car? Another one is you want to buy a house. You want to get an idea on the process of purchasing a house. Okay, for this one, guys, there are certain things that you need to have in order to be able to purchase a house. For example, these are the key factors in purchasing an expensive item in payments. First of all, you must have a job. No job, nobody's going to give you no money. Because the money that, for example, that the car costs or that the house costs, you're going to borrow the money from the bank. Then you have to pay him back plus interest. So if you don't have a job, well, then there's no car or no house, because no one's going to offer you, qualify you for that if you don't have a job. So you must have a job, number one. Number two, you must have very good credit, or even good credit is good enough. But the better the credit, the least interest you're going to pay. Okay, that's how it is. Okay. Now, the next thing is that you must get pre-qualified for the maximum amount of a loan. For example, if I think nowadays no agent is gonna take you to purchase a house unless you're qualified. Because here's why. Say that you want to buy a house, right? And then say you don't know how much money you can afford. What's the maximum credit that you're going to get? Okay, so let's say that you want to look at houses, and then you go looking for houses that are worth, like, say, $300,000. Okay, and then you'll be looking at houses on that range, say between $250,000 to $350,000. But then once you get qualified, you only qualify for a house, like, say, $150,000 or maybe $200,000. You see, so all the houses that you looked at were real nice, right? But you don't qualify for those houses because you don't make enough money. To get the credit for those houses. So then you'll be looking at houses that they're not as nice as the ones that you looked at. So now everything that you look at your range isn't going to be as nice as what you want. So more likely you're going to get, like, the cup said, because you were looking at houses that were way over your budget. So it's always good to get pre-qualified first, and the agent is going to tell you that you need to get pre-qualified, and this way you know how much money you can afford. Okay, now let's say you want to buy a new car that costs $26,750. What are your monthly payments if the interest rate is 4.2% and that the loan is for 5 years? And also, how much interest did you pay? How much more extra did you pay in interest? Okay, so there's my formula, right? Different formula now. So we're looking for, right, for the monthly payment. So we're looking for the payment. The present value means how much money did you borrow from the bank at the present time, right? So that the present value is how much money you borrowed, which was $26,750. The interest rate is 4.2%, which results in 0.042. Right, monthly payments means the compounded is 12. Because for cars and also for homes, is the M is always 12, compounded 12, because they're always monthly payments. Okay. The T, right, is for 5 years. And the I will be R divided by M, will be 0.042 divided by 12, will give us 0.0035. The N is M times T, will be 12 times 5, will give us 60. Now we just plug everything in the calculator, right? We plug everything in. And again, we're going to use it with one steady flow. So the first thing we're going to do, we're going to input, right, the numerator. 1 minus parentheses 1 plus 0.0035 close parentheses to the negative 60. And this is what you see on your screen. 0.18911.85031. Then, right, then you're going to hit the division key. And this is what you should see on your screen. Answer, right, divided by. Now you're going to enter the 0.0035, and you're going to enter that. It's going to result in 54.033.85802. That's what you should see on the screen. Now we're going to hit the inverse key, right? Because we're looking for the payment, so we'll hit the inverse key. And this is what you should see on your screen, right? The answer, which is this answer to a -1, means the inverse. Then you're going to enter the 26,750. And this is what you see, $495 and 6 cents. So your monthly payments are $495.06. Now, how much money did you end up paying, right? So it wasn't $26,750. That's how much the car cost from the beginning, right? But you have to pay interest. So we made 60 payments, right? There were 60 payments that we made. So we're going to multiply the 60 times the payments, which will give us $29,703.60. So we subtract the $26,750 from what you end up paying, and you end up paying an extra of almost like $3,000, $2,153.60, which comes out to about $3,000. That's how much money extra you paid. Okay. Okay. Now, how could you avoid paying the extra $3,000 in interest? What you could have done is you every month you pay a little bit extra, whatever you can afford. Say $100 extra every month, and this way you end up paying. You will end up paying that much money at the end. I mean, that much interest at the end. You can eliminate some of the interest by paying extra every month or whenever you can. Okay, that's one thing to consider. Okay, now I believe this will be the last one, and this is for buying a house. This is our dream that every student wants to buy their own house. Okay, so say you want to purchase a house that's worth $325,000 with a 30-year fixed rate at 3.9%. What are the monthly payments and how much interest did you end up paying? Okay, now guys, when you purchase a house, it's a big investment. Okay, a big investment. And the better your credit score, or the higher your credit score is, the less interest you're going to pay. They might also offer you, right, if you qualify, that you pay 20%, and you can get it for 15 years instead of 30. And because that's what I did when we purchased a house about 3 years ago. Instead of 30%, of 30 years, we went for 15 years. But we had to pay 20% down of what the cost cost. And also my interest, we got it real cheap because it was during COVID. So I think our interest was like 2.795%, something like that. But nowadays, the fixed rate interest is about, I think, between 5 to 7% more or less. It's kind of high. Okay. But anyway, let's do this scenario here. There's my formula. Right. This is again, we're looking for the payments, right? How much are the monthly payments? So the money that we borrowed from the bank was $325,000. The interest rate is 3.9%, which will give us 0.039. My M is again monthly, right? Because most houses and cars, the M, the compound rate will be 12. The time is 30 years. So the I, which is R divided by M, will be 0.039 divided by 12, will give us 0.00325. And the N will be 360. Every time, guys, for a mortgage, if it's 30 years, it'll be 360. Okay, so let's plug everything in, and we'll see how much money will be our monthly payments. So again, right, by using the TI-83, TI-84, I'm going to plug it into the calculator with one steady flow. So first, I'm going to input the numerator here, which will be 1 minus parentheses 1 plus 0.00325 close parentheses, to a negative 360. You can enter that, and you see 0.68, 904, 36, 901. Then we're going to hit the division key. So divided by, this is what you should see on your screen. And then you're going to enter the 0.00325. Enter it, and you're going to have 212.0134431 on your screen. That's what you should see on your screen. Now we're going to hit the inverse key, and then we're going to, and this is what you should see. Then we're going to enter the 325,000. So these are our monthly payments, which would be $1,532.92. Okay. Hey guys, but also guys, there's also some other things that they're also on the payment. You have to have house insurance. Until you have until you pay the house, you must purchase insurance. And also there's also property taxes. Okay. At times the property taxes and the insurance is included in your payment. So this payment here, guys, is just for the house, but for the insurance and also for the taxes, it'll be like another maybe like another $500 or $600 extra. It depends where you live. Now, you can purchase a house on the east side or the west side. They'll be about the same price, more or less, right? Because it's expensive to live on the west side or far east. If you live in northeast and also on some places and also on the lower valley, you might get the same house, but on the lower valley or the northeast, the house is much cheaper than on the east side or the west side. It's just because of the area. And also on the states like Socorro district, they pay a lot of property taxes compared to the Isleta or the El Paso districts. Socorro pays more interest. Okay, that's something to know when you're going to purchase a house on what area of town you want to live at. Again, these are my payments, and we made 360 payments, right? So we multiply 360 times the $1,532.92. That's going to give us $551,151.20. That's how much you end up paying for the house. Okay. So how much interest extra did you pay? Right. So we subtract that amount minus what you borrowed from the bank. So you paid over $250,000 in interest. Isn't that amazing, guys? That's a lot of money. Now, you can avoid those payments. I mean, all that extra money. For example, if you qualify for if you could afford to give down the 20%, then and get it for 15 years, then it won't be nearly as much as that paying extra. I think you'll be paying like less than $100,000 extra, so you can double that. I mean, you'll be paying like double less than that, maybe like 60,000-70,000. Okay, because that's what I did, and the total money that I'll be paying extra is about 60,000 for 15 years. So again, it depends what area of town you live, or I mean what area of town you want to buy the house, and also if you have extra money to put the 20% down, do it. In the long run, you'll be paying a lot less interest. Okay, I believe that's it for this PowerPoint. I just want to thank you for joining today's Friday Happy Hour. So let me take you back to the host so they can end this workshop.
Thank you very much, Mr. Isasi, for that wonderful presentation, that insight on interest rates and buying a home and saving money. So thank you very much. If you don't have any questions, Areli, I invite you to join us later on today for a presentation for the Student Success Department. Pasos program is doing a presentation on Cesar Chavez and an oral history project at 1 p.m. Next week is, of course, spring break. So enjoy your spring break, enjoy your time off. And we'll be back on March the 21st, which would be Happy Math Hour, Math 1324, Exam 2 Review, and Math 1314, the same thing, Exam 2 Review. If you have any questions, Areli, you can go ahead and open up your mic and ask Mr. Isasi. If not, have a wonderful spring break and be safe.